Hi folks, welcome to another episode of NYC CNC. Let's talk about boring bars. If you remember, about a month or so ago when I was making the jacket drawing dies, I was unhappy with the boring bars I was using that were these carbide-brazed Asian import guys. These are pretty cheap. I'm guessing, I think you can buy a set of these for 20 bucks or something for 9 of them. Maybe it's more than that. I don't really remember, but they're cheap. And the problem I was having wasn't so much the cut. It was cutting okay. It was just leaving a really rough finish. And that's a function of the fact that the tips on these guys there's not much, if any, radius on them. And you can grind carbide, not as easy as grinding HSS. You can use a diamond wheel. But nevertheless, these are what they are, which is inexpensive import quality tools. So at the time I thought, let's just make one. Well, I had a project, I think it chucked up in the lathe. I really needed to get it done. And so I ended up buying this guy from McMaster. It's a carbide insert boring bar, much higher quality. It is, as you can see here on the website, about 33 bucks, which I wasn't crazy excited about. McMaster stuff is great. It's just you pay for it. But it has they call it a 1/64th inch radius, which is about 15 thousandths, which I thought would fit the bill. And sure enough, I got it and it worked great. So right now I don't actually need a new boring bar, but I was talking to my buddy Brad over, right now a project he's got going on is called Taipan, but he's run a bunch of successful Kickstarter campaigns, as you can see here. I bought a number of his stuff, the titanium keychain and the bottle grenade, pretty cool stuff. He's also got a Tormach mill. Great guy. He sent me some titanium that I've been playing with, which is fun. Anyways, he sent me this picture here of one he made. And as you can see, he's got an insert version on the left. I think he ended up modifying that one, but the one he made is on the right. I want to say that there's two ends here. One of them was actually a radius boring bar. The other side of the same tool was for ID threading. Super creative. And he sort of mentioned, hey, no big deal to make one of these things. You just got to do it. So let's do it. I've got a piece of 3/4 01 here, and I mocked up a design in a Libre. This is what I've come up with. I'm may end up changing it as we go through and make it, but I thought what I would do at least is walk you through how I made it, in case there are folks who are watching who wanted to see. Really only takes a minute or two to make something like this. In a Libre, what I did is I started with this sketch, which you do by just creating the lines. You then revolve that around the axis, and you end up with this guy right here. And then added a fillet to the end tip, and then let's see, what was this? The extrusion. I cut it on the plane. So that gives us the half profile, and then so that we don't create a stress riser, the idea is to have a fillet there as well. So that's the general idea. This obviously would contemplate being able to cut on both sides. Probably not important to me. We'll see how it goes. The general idea, though, is we'll chuck this piece of O1 up in the lathe, and we'll do our turn machining, obviously in the lathe, and then we'll stick it in the Tormach and mill away the half that needs to be removed, so you get the cutting tool. And who knows, maybe I'll even end up trying the surface grinder to finish, I hadn't even thought of that, to finish the the height of it. Anyways, thought it should be a fun project. One thing I noticed, which I was kind of surprised about, I feel like when I bought 01 before, it's pretty spot on in terms of dimension, but I threw the mic on here, and this stuff is miking out about 15 over. 13 and a half. So it's 13 and a half over, so 763 and change, which I was surprised about. 13 thousandths is, that's a lot. I don't even get extrusions that far out. And the tool we've got here, just for reference, is, I measured it beforehand here, is about half a thou under, actually not even, 749 and we read our vernier here, 7/10. I'll call it 8/10. So, 2/10 under 750. And that's actually a slightly lighter fit than I'd like in this tool holder. It's okay when you tighten these down. It's not going to be a problem, but I wouldn't mind it being just a smidgen tighter even than that. So that's enough talking. Let's go hop over to the lathe and start making some chips. Almost forgot to mention, the cool thing about this project is we'll obviously want to harden the tool, or at least harden the cutting edge. So should be a fun project. We'll turn, we'll use the Tormach PCNC mill, we may use the Tormach surface grinder, we'll grab the oxyacetylene tanks and heat treat it. So should be a fun project to kind of make use of a bunch of tools. Actually, before we head over to the lathe, let's make a quick drawing that we can print out and bring with us. I find that it's helpful to have that as a reference, and I've got enough projects going on lately where I hate to try to keep things in my head. It's just not always wise. New drawing. Scale 1:1. Oh, sorry, here's the scale. We want 1:1. We'll add that ISO view. And let's see here. It was on the other screen. Here we go. Okay. So we'll make the obvious one, which is we want that to be 750. We want this length to be 2.125. Let's see here. Oops, hold on. There we go. Perfect, so that's obviously 1/8 of an inch. And we want this to be 275, which means we'll turn the total down to 275 times 2, which is 550. Let's see, what else do we need? I don't think anything. Yeah, that should be good. Let's print this out and we'll have it to tape up next to the lathe. Before we start cutting, I actually wanted to show you, I'm going to try borrowing a buddy's hard disk drive camcorder. I think the quality should be okay. What I really like about it is the viewfinder lets me see the camera angle without having to, fix my head all the way back around it, which is kind of a pain. It's nice to sort of see your hands live, if you will. And it's also a slightly wider view, which will be great for some of the shots I've been trying to get. And the other thing is it's now getting cooler out here, so I switched my lights back to these bulbs I bought from B&H that are crazy bright. They get really hot, which I don't like in the summer. Normally I run just CFLs, but they provide a lot more light, which will be really nice. So let's see how this footage works. I'm going to turn off the DSLR that I'm shooting with now, which is a Canon T2i, and we're going to hop over and try out this camcorder. Okay, got our part dialed in the forward jaw. We left off 2 dimensions in our drawing. Overall length is 4 inches, and for now at least the OD of the tip where the cutting tool is the full 750. So what I did, we're not too worried about the precision of the length tolerances here. I took a Sharpie. The first line is the hole we drilled for our center drill. So we will have our cutting tool area between these 2 lines, and then this area here is the 2-inch relief that will turn down to 550. We are going to use a dead center since we've got the part extended out over 4 inches here. So let's go ahead, put a little bit of oil on that. Okay, perfect. Okay, let's grab our cutting tool. So let me think about this. You know, I think what I'm going to do is use a part-off tool to come up against the ends, because I won't be able to get in there with my angled tool bit. So we'll come in and part down. So let's see here. I always use my calculator, even though the math looks simple. 750 down to 550 is 200 divided by 2. So we need to go 100 in. Set our dial to 0 here. Let me move the camera so you maybe can see my hands a little more. The other thing this camcorder does that my DSLR doesn't is it auto-focuses. So if I move my hand up in here, it'll focus on a part or a ruler, which will be nice. You hate to lose focus sometimes. Okay, we've got our wheel on 0. We're going to go slow here. We'll just do it at 245 RPMs. We're happy there. So we're going to come in 100 and see how that goes. Okay, coming up on 70. Okay, we had a problem there. The edge doesn't look bad, but it's not getting a good cut. So that means we are either have a bad edge, or more likely, actually, we are cutting below center. So let's see how that looks. Actually, we can do the ruler test real quick here. Some guys are really good at this. I don't love it. But the idea is that when you're holding a straight edge like this between the tool and the round diameter, see, that's pretty darn straight up and down. Let's compare it to the point on our dead center. You know, maybe come up a hair. It's not much, but parting can be fussy like that. That's too much. Okay, let's try that. Okay, well this is frustrating. I thought I had the camera on record and it looked over and it's on standby, so I'm not sure. I'll have to take a look here, see what we missed. Actually, we'll just remeasure here where we're at. 588, so 19 more to come in. Yep, that looks about right. I forgot to put our dead center back in. Not good? Okay. Oh, actually, sorry. That was embarrassing of me. I realized why we were bottoming out. It was not at all due to the blade height. It was because our quick change tool post was hitting our body here. So there's no good excuse for that. I'll tell you, videotaping can be distracting sometimes, but that's not a good excuse. So we will move our tool out here a little further. Let's see here. Yep, we'll just loosen this screw back here. Slide it out. Having the viewfinder and autofocus makes this little type of footage a lot nicer to do. These phase 2 Chinese holders, the only thing I don't like is the parting tool holder. When you pinch it down, you're pulling this wedge back against the top of the bar. It tends to drive the top out at an angle, and in fact, you can see get the camera angle right here. You can see it's at a slight angle. So I'm thinking about making my own or buying. Maybe I'll buy just an Aloris US high quality version of the parting tool holder. Okay, we don't have too much further to go, so that should be enough. Yep, still 19. Okay. It just shut off on me again. Come in 60 more. It's a nice cut here. So I want to break that chip. Just start and stop the power feed and you'll break that long curly chip. I don't want that catching on anything, mostly me. Get these chips out of here. It's a warm part, that's for sure. Come in 30 more and then we'll take a final pass. I'm sitting here watching the camera, and of course now it's not turning off on me. I'm 3 minutes into a stretch here, so I'm not sure why that's doing that. Okay, coming up on the end here. Okay. Now the part's quite hot, so this measurement will be approximate at best. We're at 584. So we've got another 17 to go. So let's go ahead and take that. Coming up here on the end. Really happy with the cut quality on the first half. It got a little scraggly there. I'm gonna let this cool. We'll be back in a minute, and we will use some sandpaper. Clean that up. Let's just see them real quick. 548. So we're 2 thou under. That's okay for this application. We're just going for a rough diameter. Okay, perfect. So I'm gonna let that cool. We'll be back in a minute and clean it up and finish off our lathe work. I'm taking a quick cleanup pass, just a few thousandths, if that, to get rid of some of the right half here was perfect, but there was some wasn't happy with the cut quality on the left. I also uploaded the footage up until this point and took a look at it on the computer. Happy with the camera, but wasn't happy with the audio, so I switched back to my lav mic, which should be better. I don't like the lav mic is wired, and I really don't. I'm tired of having these wires between the camera and the mic. It just doesn't feel safe. Okay. Perfect. Now, let's do this. I'm going to take this tool out, and I'm going to replace it with this tool, and that'll let us come up here and sneak up and take off a little area here on the left that we couldn't get to before. These are the same manufacturer and brand and insert, so I don't need to worry about tool height. What's in there? I've had on my little wish list to buy a few more of these tool holders, but I've also thought about making some. Seems like it would be a very fun project. The problem is it's probably just not a good use of time. With other projects I've got going on, it would be fun, and there's something about making them yourself that is very satisfying. So we'll see. I may still end up buying one or two to tie me over in the meantime. I think they're like $25 from Enco, so it's really not too expensive. Okay. Again, the point here, I'm not worried about dimensional accuracy so much as I am. I just kind of want a nice smooth surface. So, go over here. Okay, that actually cut much nicer, which tells me I probably need to change the insert in that other tool. I'd be lying if I said I change them proactively. I like to kind of get the most life out of them, especially if I'm not working on a absolute critical part. So let's grab a piece of sandpaper here. Now, I normally put a towel down. We'll use a paper towel for now. We're not going to do too much sanding here, but I like to be careful. Okay. It's amazing how much that cleans it up. It looks great. So I am very pleased with that. Now, on the back side here, all we're going to have to do is part it off, and it doesn't even need to be perfectly square. It doesn't serve any dimensional role. But we do want to see here, we've got the sort of problem that we are, still 13th hour or so over on the body here. So let's just go ahead and deal with that. And we'll switch our tool back. Now, okay, let's touch off, and we'll touch off, and then we'll take 6. Okay. Let's get a new insert in there. I think that's shot. Okay, let's see if this does any better. I bet it will.